Alright, so here's just a general introduction into the Formula SAEonline.com website. So first thing you're going to need to do is to log in. If you do not already have an account, you'll go over to this create an account page. You will fill out your general information, username, password, etc. up here, and then you will want to select team member. And then when you hit next, it'll ask you to describe which specific university that you belong to. You would select Clemson or whatever university you're at, and from there your team captain or whoever is the team captain for the team on FSCE Online will be able to approve your membership to the team, and then you will actually be able to access the online cost report system. So once you do that, you can log in. Alright, once you log in, you will be presented with this initial page. Obviously, you are not going to see this top part, but you will see these lower two sections. So in team member section, you have my team's report document submissions. That's where we submit the structural equivalency sheet, or SES, the business logic case plan design report, etc., etc. Here we have the ask a rules question, in case you have a specific question about the rules that you want to officially submit to the rules committee for Formula SAE. And we have a couple other things about rules, email address. In case you find any bugs or any other major issues in the online cost report system, that would be the email address that you would report those issues to. And then lastly, of course, we have the online cost report system itself. Keep in mind that all of these features are also accessible up in the Jump to Activity tab up here. So if you go up here, we have the 3 different categories, which represent the 3 different categories that we see here. Team captain. All of these options here are the exact same options that appear here. So we are going to go to the online cost report system. And here you can see the different vehicles that we have currently. We have a test vehicle that was used way back when I was just kind of fiddling around with the online cost report system to begin with. Then after that we have, this is the actual online cost report that we submitted last year. This is a copy of that submission. And then up at the very top we have what this year's cost report is going to be. Now, first off, we're going to quickly go over the general understanding of what breaks down the cost report itself. Alright, so here we are looking at the actual Formula SAE rulebook. This is page 137 of the most recent version, statics 4.10.2. But here we have an actual breakdown of what the cost report hierarchy looks like. So at the very top of the hierarchy, you have the actual car itself. And then the competition rules break down the car into a set of different systems that have very defined parts that go within that system. So in this particular case, we have the engine drivetrain system, and within that system is contained the engine assembly, as well as the differential assembly, etc., etc. So the next breakdown would be assemblies, and then within assemblies you're going to have parts, although that is not necessarily true. For example, up here we have an engine that is simply an assembly. That has to do with more of a simplification of the rules so that teams don't have to cost out all of the different parts of an engine and just treat it as a single lump sum cost. So within an assembly you're going to have parts. So some of these parts are going to have actual materials and stuff. So this is where the actual cost report side of things comes in. This is where the actual work is, really. So each part can be broken down into a couple of different categories. The first is a material. So material is whatever thing that you started with before you actually had your part. So this can take the form of raw metal, so in this case aluminum. But material also includes some pre-built parts. So we have needle bearing here. Bearings are generally included in materials. And also a certain select popular parts are also kept as a material. A good example of that is our wheels, our OZ magnesium wheels. Those are kept as a singular part, so you don't have to cost out the manufacturing process of casting and forging a magnesium wheel. Next, we have processes. So these are anything that you do to your materials. So process can be assembly, process can be machining. In this particular case, we have some sand casting. It can be welding. But it's whatever you did to your material to get the part out. And also attached to some processes is our tooling. This is mainly limited to any casting operations, any composite reinforcement, so the actual mold is considered tooling. And then also, I believe for the chassis, a welding rig, a jig, is also considered tooling that is mandatory. So we have materials, we have processes, we have tooling, and then lastly we have fasteners. So fastener is simply going to be a bolt, a C-clip, something that actually holds the entire part together. So now that we have that general breakdown of what the actual cost report looks like, we can actually go into the online cost report system and see that in action. So let's go ahead and look at the old cost report real quick. So I'm going to go into Manage Cost Report. That's how you access the actual internals of the cost report. And you can see here that we have our vehicle systems, all 8 of them. And let's, for example, look at brake systems. So under a system, you're going to have your assemblies. So naturally, we can click Manage Assemblies. So we have 3 assemblies here. We have hydraulic lines, brake caliper, and brake rotor. And they each have their individual part number as defined by the actual rules here. A quantity, if you have, for example, all of the, you could have easily broken this down as having brake rotor for the front and brake rotor for the rear, and then just say I have a quantity of 2 for both of them. That would be a valid way to break this down. So let's look at the brake rotor assembly. So you're going to click View. And here we can see the different parts of the actual brake rotor assembly. First, at the top, we have the title of the actual assembly itself, a description of that assembly, the part base number, the part suffix, and the actual quantity up here. Next, we have the actual parts that make up the assembly, and then also we have the materials, processes, fasteners, and tooling that I had talked about before. So whenever you have an assembly of parts, there might be some small pieces that end up connecting everything together that you don't necessarily think deserve an entirely another part name or part number on its own, but still needs to be costed out. This is where that would go. So for example, here we have our brake rotors and then bobbins. If you do not know, bobbins are what hold the brake rotor onto the hub of the actual upright assembly that holds on the wheel. So in order to actually put these things together, we actually need some fasteners pretty much. So as a part of processes, we have an assembly process, which is to take the brake rotors and put them onto the hub. So we have an assemble 1 kilogram loose fit, and then we have an assemble 1 kilogram line on line for putting the bobbins into the holes of the rotor itself. And then also bottom here we have the actual cost of the fasteners themselves. So let's look at one of the actual bobbins real quick. Let's look at the front bobbins. So here we have, again, at the very top we have our title, we have a description, a part base number, and a part number suffix. So at the very top we're going to have material. We're starting off with steel alloy, how much material is actually needed per bobbin. Then we have the individual processes themselves. So start up, we have a machining setup, install, and remove. a machining setup change, the actual machining process itself, and drilled holes. And then we don't have any fasteners that are associated with this particular part, nor do we have any tooling associated with this part. So that's basically where that ends. So that's just a general overview of the actual entire cost report system, how it's organized within the online system itself. Now that we have a general overview of the different items that go into the individual costing of each part, you might be wondering, how do I figure out what materials, what processes, fasteners, or tooling are actually available to enter into the system? So at the bottom of every single part, and then also at the Manage Vehicles page, you can see a browse of the current cost catalog tables. And these are simply a listing of all of the different materials, fasteners, process multipliers, and tooling that are available for each of those categories. So let's look at materials first. So inside materials, this is easily the largest table that is in the cost report. We have all of the individual, both raw materials and parts that can be possibly used within Formula SAE. So you can organize them by material, supplier, category. Then we have some information that they give, a short description, cost, units, if they have to be costed out in a certain specific way. So if we go to supplier, we have mostly OEM suppliers, including any and any OEM. So I mentioned before the fact that OZ wheels are something that gets costed as a material. It's already given to you. So if we scroll down to OZ Racing, we can see that wheel 1-inch, one-piece magnesium is already a material. So in order to cost out the wheel, you literally just add that material to the part called wheel, or an assembly called wheels. We can easily look at this for other things. For example, Motec provides our ECU, engine control unit. So if we go down ECU, we use an M150, and you can see it is right here. So again, you would just need to add that specific material in. And if you have any difficulty finding specifics, so we also, in addition to the very specific brand name materials, we also have some more generic materials. So for example, if we go into, let's say, plumbing, you can see we have just a general adapter here for all kinds of different things, aluminum anodize, etc., and so forth. So in addition to any specific manufactured parts, you're going to have some generic parts. If we scroll back up to bearings, for example, we have ball bearings, steel, angular contact, deep groove, etc., etc. In addition, on these categories, we have some other very important ones. Materials is a big one. So if we go up to composite, which unfortunately is not to be confused with composites for reasons unbeknown to me, we can see that we have each of the individual plies of any kind of reinforcement that we could use in any composite or carbon fiber layup process. So we have our individual fiber, cloths, honeycombs, structural foam, etc. So, and we also have general raw materials. So raw materials are broken up into two different categories. We have raw material and raw material per kilogram. So raw material is generally going to be all of the same materials that you're going to have in raw material per kilogram, except you tell them generally the actual dimensions that are used to make up that specific raw material, rather than telling them how many kilograms of a material you need. So for example, we have iron by dimensions, magnesium by dimensions, Inconel, etc. In addition to metals, we have plastics. I believe we should also have some rubber. Yep, we have rubber here. And wood. If you can't find the raw material that you are looking for in raw material, check per kilogram. There are some that are in raw materials, some that are only in raw material per kilogram. It's kind of random from what I can tell, but be sure to check both. The one thing that is definitive between those two categories is for raw material per kilogram, you tell them how much, like the actual mass of whatever material that you're trying to use. Last thing I'll point out here is the incredibly convenient search function. So if you really don't want to try and go through your categories or your suppliers, you can simply just go up to the search box. Let's say we're wanting to look for rod ends. So if I type in rod end, we can see that we have 3 different rod ends right here to choose from. Or if we want spherical bearings, boom. Bearing spherical just by typing in half of the word spherical. Now within every single table entry you have this button on the right called View, so that will give you some more detailed information about what specific table entry you are looking at. When it comes to the actual costing of the generic parts, in this case a spherical bearing, you have different sizes that are used to approximate how much that item would cost. So for a spherical bearing, we can see that the size that we actually care about is the diameter of the actual hole that is used for the spherical bearing. And that should be given in units of millimeters. Sometimes you'll have a description here, common names label, but overall, this is generally where it breaks down to. And then also you can see down here we have the cost report formula itself. If you hit this little question mark, we have all of the actual math operators that can be used, just so you have an understanding of where the actual end cost is being calculated from. And this is actually a new section that I just now noticed, honestly. Apparently you can actually type in one of the sizes and get a calculated unit cost as an approximation. So a 12 millimeter bore would cost $9.32. Alright, so now let's have a look at fasteners. So here are the fasteners. There are a lot less options here. As you can see, supplier is completely blank because they're all generic fasteners. Category also blank because the category is a fastener in general. So we have bolts, clevises, Zeus fasteners, all kinds of random stuff. So if you need anything in specific, I generally would recommend using the search function, or if you're literally just starting out using the cost report system, just take a second just to kind of go through them and understand what's there, what's not, what you can actually look for. And then again, when you click View, you have the general title, which should be generally fairly self-explanatory, and then you have the general size labels itself, so the diameter and the length. So whereas before in the spherical bearing, we only had one size to enter because only one size label was filled out, here we have 2. So if we say we have a 30, 30 is ridiculous. So we have a 5 millimeter bolt. It's tiny. And it is 20 millimeters long. Now we can actually have a calculated unit cost. Next we'll be talking about processes and process multipliers. So here we have the different processes that are used to actually make the part that you are going to be costing out. So here we have categories. This is where you're generally going to try and find what you're looking for in particular. The big, more confusing ones is probably going to be assembly, which is under labor. So assembly basically breaks down into a different set of weights and then different versions of an assembly. So interference is something that gets press fit in, so it's an actual interference fit. Line on line simply means you'd have to line something up together in order to get it to go through. So an example of that would be something like a clevis or something like that, where you have to have the actual clevis go onto a singular part and have a bolt go through it. You have to line up your holes, hence the line-on-line name, in order to actually assemble it together. And then lastly, we have loose, which is literally just kind of put it on there kind of stuff. It's not line-on-line, it's not interference, it's just kind of put it on there. And we have all the different weights that are available for that. Then, of course, we have some electrical ones. And also, if we scroll back up, coating, composites, fasteners, all of them are fairly self-explanatory. If you're confused about any of them, feel free to hit the view, in which case there normally is going to be some kind of description that will help you understand what exactly it is for. So for every process, you're generally going to have a process multiplier. And this is something that is simply used to take into account certain properties of that process in relation to the specific instance that it is happening to. So in this particular case, the most common one is going to be a material multiplier. So obviously, some materials are going to be more difficult to machine than others. So we can see that wood, hard or soft wood, actually has a multiplier of 0.5. So you're actually going to be gaining back money compared to other machining operations. Stainless steel has quite a high multiplier, 3.75. The highest multiplier here is going to be MMC, or metal matrix composite, and right up with Inconel at a level 4. In addition to those, we have repeats. So if you're having to do the same process several times for a specific part, you can just, instead of putting that process down multiple times, you can just put a repeat on there in order to actually just double or triple or however many the operations or processes that you actually need to do. All of these other ones are fairly self-explanatory. So if you're doing a drill and tap where your hole length to diameter ratio is greater than or equal to 4 or greater than or equal to 8, that's when you're going to start to use these multipliers, and you're going to have to actually use the system to calculate what that multiplier is actually going to look like. All right, last up we have tooling. So tooling here is simply just if you're using a specific process that requires a specific tooling. So for example, if you're using die casting as a process, you need a die. If you're doing any kind of lamination, so carbon fiber composite stuff, you're going to need an actual lamination tool, a mold. So in this particular case, it's broken up into a flat panel tool, something that can be made out of sheet metal, something like that, or a mold tool, which is something that is a much more complex shape, needs to be milled out of a foam of some sort in order to create the proper mold itself. And otherwise, we have pouring fixture. This would be for something along the lines of making a carbon fiber seat. Powder metal forming, again, and that's another die. Sand casting is a die, more sand casting stuff. And then lastly, most importantly probably, because it's going to be the most applicable to everybody, it's going to be welds. So welds need a welding fixture, and that fixture cost is defined by how many different fixturing points are required in order for the chassis or whatever piece is required to be complete.